Hello mates, in the previous videos we were doing the first equatorial system and we saw how to get the declination and the hour angle. But then at the end of the video we started discussing why the equatorial system, the first equatorial system wasn't sufficient. It is because when the celestial sphere is rotating, the hour angle will also change. So we wanted a system where the hour angle does not, the coordinates that we are going to use do not change with time. Otherwise, referencing a star using things that change with time is a bit difficult. So we wanted a system that does not change. So the astronomers developed the second equatorial system, and we are going to look at the coordinates that are involved in them. So now, for the second equatorial system, we are going to choose an origin that does not give us coordinates that change with time. So basically, for us to have such a coordinate, for us to have such an origin, let me write this: equatorial system. Multitasking there was killing me, but yeah, for us to have such an origin that doesn't change with time. For the first equatorial system, our angle was measured from a fixed point. That was where the celestial meridian was meeting our equator. And as the sphere was rotating, that point remained there on top. Okay, let me just draw a quick diagram just to demonstrate what I mean. If this one was our NCP and this one was our SCP, this one our zenith, this one our nadir, then definitely our equator was going to be like this. This one was going to be our celestial axis. This one was going to be our origin, because that's where the celestial equator meets the celestial meridian, the observer celestial meridian. That's the origin of what? That's the origin for our first equatorial system. The problem with this is when this celestial sphere rotates, dragging all the stars with it, this origin remains constant because of its definition. Its definition says where the celestial meridian meets the equator. So no matter how this sphere is going to rotate, the origin will still remain up there. So it means this star that was measured like this, when it rotates and the star is now here, it is now further from the origin than it was already, which means the coordinate that we are measuring from this origin would change with time. It will change with time because these stars are moving, but the origin isn't moving. So that was the major problem with the first equatorial system. So that's what they tried to overcome when they created the second equatorial system. They chose an origin that moves with the celestial sphere. What that basically means is, if this origin is going to move along with the celestial sphere, it means, okay, let me just say this in simple terms: the distance between the origin and the star will remain constant because they are moving together. If the distance was like this, they are moving together along with the celestial sphere, so the distance remains constant. But imagine this was my origin and this was my star. In the first equatorial system, the origin remained constant. So as the celestial sphere was dragging the stars, the star would increase distance, go right round, the origin would remain constant, and then come back and then go around. So it meant at every instant it would have a different hour angle in the first equatorial system. But in this system, we want an origin that moves along with the celestial sphere. It basically means if we use a coordinate from that origin, then that coordinate is constant no matter what. It's just going to remain constant. That is what the second equatorial system is all about. Actually, I spelled the equatorial system wrong. It's supposed to be having an A here, not an I. So now we know the Earth revolves around the Sun in an orbit which lies in a fixed plane containing the Sun. Yeah, these are technical terms that try to describe the path of the Sun. The Sun does not travel in a straight line like this. These stars, when the celestial sphere is rotating, these stars travel in paths that are parallel to the equator, like we saw in the previous sections. That these stars travel in paths that are parallel to the celestial equator. But for the Sun, the path is totally different. The path is not parallel to the celestial equator. The plane of the the path of the Sun, the plane containing the sun's path, is called the ecliptic. It's called the ecliptic. So that is called the ecliptic. The plane of this ecliptic, so this plane of this ecliptic, it cuts the celestial sphere in a great circle known as the ecliptic. So there's going to be a great circle called the ecliptic, but now we need to know in relation to our diagram, where is the ecliptic? So let me draw a new diagram. So a new diagram that we are going to use is this. This is going to be our south celestial pole, our north celestial pole, and this is going to be our axis. And this is going to be our celestial equator. That's going to be our celestial equator, right? And this is going to be our zenith. This is going to be our nadir. And I'm just going to put points like this to mark the horizon, because I do not want to draw this circle of the horizon, because I would confuse you with the what? With the celestial, with the ecliptic that I'm going to draw now. The ecliptic has been defined as the plane of the sun's path. That when it what? It meets the great. It forms a great circle, which means it includes what? It includes the center of this circle. So let's see where to draw the ecliptic. So during the course of a year, as the sun is seen from the earth, against the background of the stars, it moves around. It moves once around the ecliptic from west to east. So around its path, it moves once. So the sun moves once around its path from west to east. So now this is the diagram we are considering. We now need to fill in the ecliptic, so that we see the path of the sun and see how the sun is going to move. The ecliptic cuts the equator in 2 points. This is the celestial equator. Let me label that so that you see. This is celestial equator. So since that is the celestial equator, the sun, the ecliptic, the path of the sun, cuts the equator in 2 points on opposite sides of the observer, known as the equinoxes. So this is what I'm going to do. I'm going to draw in the ecliptic. The parts of the other stars, they are parallel to the what? They are parallel to the celestial equator. So they do not cross. Let's say they do not cross, isn't it? Because they are parallel to this. But we are told that the ecliptic cuts the equator, which means it crosses the equator. So it is the path of the sun is not parallel to this. So let me draw in the path. I'm going to draw in the path like this. And then it goes at the back. So now this is the path of the sun. And as you can see, it's not parallel to the celestial equator like this star above here. This star above here, its path is parallel to the equator, but the sun's path is not parallel to the equator. And as they said the equator, as I said, this ecliptic, let me label it. Ecliptic, the path of the sun. So that ecliptic, that great circle, it cuts the celestial equator at 2 points. And as you can see, it cuts the celestial equator at this point and at the point behind there. As you can see, those are the 2 points where it cuts. And those points, they are given special names. They are called equinoxes. They are given a special name called equinoxes. When they're together, they are called equinoxes. But the equinox where the sun is crossing the celestial equator, going from south to north. So when the sun is going from south to north, that equinox where it now cuts the celestial equator, it is given a special name, and it's called the first point of Aries. It's called the first point of Aries. First point of Aries. It's first point of Aries. So now when we're looking at our diagram, let's see where our west and our east is. So with this diagram, I can see that my what? My west is this side and my east is on this side. That is where my east is. My east is on top here, and my west is at the back there. So we are told that when the sun, we are told that on the equinox, the path of the sun moves from what? From west to east, as seen from Earth. It moves from west to east. So the sun comes like this. It comes from west to east, and then goes back, and then comes back like that. So now imagine the sun is here at this point. Imagine that is the sun at that point. If that is the sun at that point, it's moving in this direction. And as you can see, this is the celestial equator, which divides our celestial sphere into the southern part and the northern part. So this top part is the southern, and this bottom part is the northern. Currently, right now, the sun is in the southern part. But we are told that the equinox, where the sun, when it is moving, and it moves from the southern part to the northern part, when it crosses the celestial equator, because that is the definition of an equinox. So that equinox where the sun is moving from south to north is called the first point of Aries. So this point here is the what? Is the first point of Aries. And it is denoted by the ram sign. It's denoted by the ram sign. So here is our first point of Aries, denoted by a ram sign. This is also called the spring equinox of the northern hemisphere, because in the northern hemisphere they will now be getting into spring. The sun will be, let's say, the sun will be going to the northern hemisphere, so there it will be spring, and in the southern hemisphere, like us in Johannesburg, it will become winter. And this happens on March 22. This is a date you have to know off by heart. It happens on March 22. The first point of Aries, when the sun is at the first point of Aries, it happens on March the 22nd. So, and people usually say it happens, the assumption is it happens at 12 noon. That's when the sun is at the first point of Aries. On March 22 at 12 noon, that's where the sun will be. It will be at this point. The point V, now this point here, this point, the first point of Aries is fixed in the sky and takes part in daily rotation, because as you can see, as we rotate like this, as we rotate the celestial sphere, this part also rotates with the celestial sphere. It's unlike the way we are measuring our angle from the origin, the fixed origin. This one rotates with the celestial sphere as we rotate, as the celestial sphere is rotating. So we can choose this as the origin in our second equatorial system, because now it is moving with our celestial sphere as it is rotating. So in the next video, we are now going to define the coordinates that we will be using in this coordinate system.